Hello, Alex Williams here, and this is going to be a um, video series, or actually, it should be just one video, hopefully, on the final project for GAM 110 for 20 SP day. We're not in our class this semester, obviously, and I would have the opportunity to sit down with different people and discuss your individual projects. But of course, we can't do that. By all means, please reach out to me. We can connect on Discord or email or whatever you prefer if you have any specific questions about your project. But I just wanted to do this to give you an idea of how to get started. I know sometimes with the final project, it's a little hard to know where to get started. Um, so the first thing you're going to do, um, let me close this. First thing you're going to do is take a look here. We have the project 4, which is the game design document. I've simplified this one, and essentially all this is just a document with 4 sections. This is an example here, um, and we're just going to get the game name and uh, the story or premise, gameplay, and the controls and the UI. So what you would do is simply go into your repository and create a new folder called Final. I think I might already have one here. Yep, Final. And then just create a document in there, game design. And then the idea here is just that you want to think about what you're going to do before you do it. It's really easy to just jump in and start coding your project, and to have it grow as you build it. But it's really a good idea to have an idea at least of what you're going to do. So again, this was, let's see, we just want the game name, the premise, gameplay, and the controls and the UI. So that's the game name. And for this one, I'm going to do Alchemy. If you're not familiar, Alchemy is a game where you just have a bunch of elements. You combine them and they produce something else. So fire and water would produce steam. Water and dirt would produce mud. Maybe steam and sand, if you have sand, might produce clay or ceramics or whatever. The idea is that you can keep on combining things, and eventually you have dozens or hundreds of items. So that's the game name. The story, was it the premise? You would just type in what the premise of the game is, combining items, blah, blah, blah. And then the gameplay, you would describe in here just, and when I submit this, I'll probably put a little bit more into this. You would put in, the gameplay, display a menu, choose 2 items from the list from existing items. It's very easy to make this game where you could type in an item that you don't already have and cheat. But you would describe exactly the logic that the game flow would have here. And then finally the controls / UI. And this game is not very complicated. And I'll put some details in there and submit it to the repository. And you would just describe that. And the idea is you want to do that before you create it and then try to follow along with that and build your game based on exactly what it was you were intended to do. It's okay to change as you go along, but it's a good idea to have an idea before you start. All right, so that's the game design document. Again, it's really short, less than a page. You don't want to go too crazy with that. And there we go. All right, so then you go into Visual Studio, create a new project, .NET, and make sure that it's in your repository before you start. So let's see, where are we? We're in Documents, Game 110, Alex Williams, and Final. So inside here, I'm going to select that folder. I'm going to call it Alchemy, and we're going to get started. Okay, so let's just jump back here for a second. I want you to pay attention to the bullet points here in the final project called Inventory Quest. Alchemy is just one thing you could do. I highly recommend trying something else. The only requirements here is that you have to have an inventory and there's a game around it. So there's a game loop. There's a menu that prompts player with choices, um, or if it's a maze game, as long as there's a choice to be made. Um, there's an inventory that can be displayed so the player can see what they have. Um, an item class or structure. This is not absolutely necessary, just that there is a class or structure in there. It could be a bag with just a list of strings, which I might be, yeah, I think I'm going to be doing that for this demonstration. I change every time I do this. I try to tailor it to the audience and how complicated I want to make it or how simple I want to demonstrate it in any case. And then lastly, a collection or list of items. List, dictionary, array, some collection that you're going to iterate through and store your stuff in. Also, the code should be well documented. Um, just again, if you've had my class, you know that documentation or comments are not as important to me as how readable it is. If you write it correctly, it shouldn't need to be documented that much. But all right, let's just get started. So the first thing I'm going to need is some object to contain my items. And for this game, I'm just going to say that you have a bag. So I'm just going to right click here, say add a class, and I'm just going to call it bag. Um, bag. All right, so we have a bag. And inside this bag, I'm just going to have a list. And for this implementation, it's not going to be a list of anything fancy, just a list of string. And I'm just going to call them items. And there you go. That's going to be where all my items are. And I'm going to have a constructor. And the constructor, which is a default constructor, is going to take no input, no parameters. And it's just going to add your basic items, the ones that you would start out in a game like this. Items.add. And we're just going to have water. I have 4 items to start with. Fire, dirt, and air. All right. So that's the constructor to make a bag. It's going to automatically fill itself with those 4 items. The next thing I'm going to do is a display method. So public display items. And I'm just going to display them. So when you're creating this, it should be a nicely formatted list. This is just going to be a list straight across. I'm not even going to bother dropping it down to the next line or numbering them. You could obviously number them and have 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10. And again, it depends on what game you make. So, so I'm just going to do, instead of this, I'm going to do a for each. For each. And I like to be explicit about what I'm doing. Item is by default in items. So for each of these loops, I'm going to have this item available to me that I can write. And I just want to write it. And I'm going to write the item, which is a string. And I'm just going to give it a couple of spaces. Maybe I'll do this just to, doesn't really matter. All right. And this should just write my items across the screen. We can always test this in just a minute. Let me just go to my main program here. And the first thing I need to do is create an instance of that bag. So I'm going to go bag, my bag equals new. And of course, it's just a default constructor. And then I'm going to display it. My bag, display. All right, so all we're doing is creating a bag with those 4 items, and then we're going to display them. I'm just going to run it quickly. As you know, you always run. Make sure you don't have any problems before you move on to the next thing. And we just have 4 items, and press any key. All right, so that's the first thing. We are going to need a game loop. So I'm going to create my usual, say, bool. I like keep playing. equals true. And then I just say while, keep playing. And somewhere in my game loop, of course, I have to have logic, which changes this to false at some point in the future. Otherwise, it'll never end. But for now, we're just going to keep it like that. And of course, this display items is going to be the first thing that goes in here. I probably want to do a console clear so that every time I display it, I get a new line. And that's that. All right, so now let's see, the second part of my game here has to get 2 items out of the bag. You have to pick 2 items. So I'm going to do it in the reverse order. I'm going to say string item 1 equals my bag dot get item. And this doesn't exist, but I'm just going to write it like I think it should be written. And then I'm going to ask Visual Studio to go ahead and fix it for me. So I do control dot, generate the method. And magically, I go over here, and there it is. I don't have to write this out explicitly. It does it for me. I could. All right. So then in here, I'm going to use this as a get item method. I could do it outside there and just say enter an item, but I want to validate that the item exists in the bag. I don't want someone to just type water or say Steam before they've actually created the item. So I'm going to say, first I'm going to say CW. I'm actually going to do that. Console.writeLine twice. Because if you remember, when it displays the list, your cursor is at the end of the list. You want it to be on the line below it. I'm going to say enter or maybe pick an item. And then I'm going to say console.read. I'll say string input equals console.readLine. And the person is going to type the name of an item. Now this is where we want to validate. We want to say if the person typed something that doesn't exist, don't return that. So we're going to say if, and it's a list, so my list has a method on it called contains. If say items dot contains the input that someone typed, then we're going to return that item. And that's a valid item. We should actually maybe make them all lowercase now. I'm just going to leave it like this. If you were doing this, you might want to change both of them to lowercase and compare them, or do something to validate without having to worry about whether it's uppercase or lowercase. But for this implementation, I'm just going to do it simply like this. And then if they don't, I'm actually going to return the word nothing. And I've done this program a couple of times, and it's kind of fun to play with this as an item. Then you can actually compare to if they add nothing to nothing, they get something. Anyway, I'm just going to return that, and I think that's all I have to do for this pick item. This is a get item. It gets an item that exists in my bag. So if I say string item1 equals get item, it's going to do that. Then I can do the same thing for item 2. I can say item 2 equals get item again. So now I have 2 items and I want to combine them. So what I would want to do here is put these into a good mechanism for doing this, or a good mechanic, is to have a crafting table, or an object that is a crafting table that you put the items into. The crafting table then compares them, says, does this make something, and then returns the something that it would make. So for that, I have a couple of things. First, I want to actually create that object, and I can do it the other way rather than just right-clicking here and say add. I can say crafting table. I'll just call it table equals new crafting table. So I'm going to create an object called crafting table, and I'm going to ask Visual Studio to go ahead and build that for me. Boom. Control dot. First thing, and now it exists. You can see it right here. I created a file called crafting table, and I go in here, and this is my crafting table. What my crafting table is going to do, it's going to have a method on it that says public, and it's going to return an item, and in this case my items are strings. So it's going to return a string, and the method is called combine, and it's going to take two parameters, which is a string for for item 1 and a string for item 2. And then it's going to compare them, and it's going to return whatever that thing makes. And if it doesn't find anything, after the logic is all done, if it didn't find, fire and water make steam, and steam and something make something. If two items don't make something, the last thing it's going to do, if it doesn't find anything, is return, would you say mistake. But then in here, I'm going to actually say compare the two items. And I'm going to do something like this. I'm going to say if item 1 equals water, or, and item 1 equals fire, then return. Yeah, of course, I don't want to, that's a nice assignment. I wanted to use a comparison here, comparison operator. So if those two things are true, then we're going to return the word steam. And the idea is that we're going to get these two things. I'm going to take my crafting table. I'm going to say table dot combine item 1, item 2. Okay. And that, when I combine them, it's going to return an item. So I'm going to say my bag dot add item, and I'm going to return that. Let me just do it explicitly here. String new item equals. So then I'm going to add it to the bag. So I have to actually create that. I can add it directly to my list, but what would happen if I did that is I would wind up with 7 instances of Steam if the player kept making Steam. So we want to say if the item exists, don't add it. I don't want to put all that logic in my main loop here. I'm going to put that logic into a method on my bag. So I'm going to say my bag dot add item, new item. All right. And then I'm going to ask Visual Studio to fix it. Control dot, add that method. And I just navigate to it by hitting F12. And here is I'm back in my bag here. And I have this list of items, and these are the ones that currently exist. So what I want to do in here is I want to say if my items contains new item, or the reverse of this, I want to say new item. Actually, I'm going to change it to item. All right, so if it doesn't contain the items, then I can add it. So I say items dot add item. If it already exists, don't add it. I don't need a list of 15 instances of the word Steam. I just want this word Steam to show up once. So that's it. That's all this does. I just wanted to validate inside here without putting this logic in my main program, and it's just a cleaner way to see that. So if I were to run this now, I think it would work. Let's see. I have water, fire, dirt, air. I can pick water. I can pick fire, and I made a mistake, or it created a mistake. And let's see if I do this. Let's see, bag. No, crafting table, water, fire, steam. So let's see if oh, see that? Item 2. There we go. Let's try that again. Um, I was comparing item 1 to water and item 1 to fire. It can't be both, obviously, ever. All right, so now if I picked water and fire, it creates steam. If I did a bunch of nonsense, it's going to be a mistake no matter what I do. And I'm not going to add 17 mistakes in there. It's just going to show up once. So everything there seems to be working pretty well. So the only other thing here is that if I look at this combination thing here, if I typed fire and water in the reverse order, it would make a mistake. We want it to actually validate both, so I would have to do or item 2 equals water and item 1 equals fire. We could do it like that, but we have to do this for every single possible combination. A better way to do this is to create an object, and I'm going to do that now, just quickly. This is, as it stands now, this is essentially enough to fulfill the requirements for the final. It's not necessarily an A. It's not, a fantastic thing, but this is definitely a good implementation. But you definitely want to flesh it out, make it more, add more validation, um, maybe make it formatted better, um, you know, reply to the player a little bit more with more contextual replies. But one thing I can do here is I can say struct, I can call it, let's say I can create a recipe. I can create a recipe structure where I say item 1, I say string, item 1, where we can clearly define exactly what a recipe is, and then we say string result, item 2, and our constructor for this would be would take all 3 items, string 1, just to be quick, I'm just going to do string I1, string I2, string result, and we can say item 1 equals I1, item 2 equals I2, and result equals R. Result, return, result. All right, so we have a constructor that, and as you know in structures, you have to assign every property some value in the constructor. Can't leave anything unassigned. So this would be a recipe, and then in my crafting table, I would have list of recipes called recipes. And I don't have a using for collections generic, so I control dot, ask Visual Studio to fix that, to put the using statement up here. So I would have this list of recipes, and then I would have a constructor here that I would use to construct all the recipes. And I would say recipes dot add, and I would add a new recipe. So I'd say new recipe, and the recipe takes a constructor, and I would put water, comma, fire, comma, and Steam. And I would do this for a bunch of different things. And then instead of having this clunky way of doing it here, I would have just a bunch of lines that look like this. And I can just add a whole bunch of different recipes. Water and dirt equals mud. Water and nothing equals mist. And then what you do down here is instead of just onesie twosie, just saying if this, if this, if this, if this, and so on and so on, you would say for each recipe in recipes. Yep. Then all you have to do is say if recipe.item1 equals that, and item 2 equals that, return recipe.result. And you can also just copy and paste this and just reverse it. And it's not this, it's item 1. You're saying if the recipe of item 1 equals this item 1, and the recipe of item 2 equals item 2 that the person selected, and the reverse of that here. So you have to reverse these so that you're comparing left to right and then right to left. And you return a result. And you're doing this for each recipe. So you could have 1,000 recipes and it's just going to run through it for all the recipes. And if I run this, I think it should work. Let's see, and I say water, fire, I get steam, water, and dirt. Oh, yeah, I made a mistake. Water and dirt makes mud. I forget how you made nothing. Maybe just, nope. So anyway, that's it. And the idea here is that I just wanted to demonstrate that you could use a structure, and it makes it a lot easier when you have a structure that contains your recipes. You logically think of what is a recipe, you define the recipe, and then you can have a list of those recipes. And rather than rewriting this same logic over and over again, which you should never do, you should never copy and paste the same logic 100 times. You just create all your recipes and then you iterate through the recipes. You could additionally make an input file that you type in. You just type a file and it reads the file and fills up the recipes with that file. And that's it. So I hope this wasn't too long. I will be posting this one to my repository. I'll probably do at least one other thing that might be a little bit different or more complicated. Just give you some flexibility as to what you can do. And again, if you have any questions about this, please hit me up on Discord or email. All right, thanks.